Good day everyone. Our lesson today is all about parabola, definition and equation of a parabola. Before we start, let's have our objectives. First, define a parabola, its meaning, and then determine the standard form of equation of a parabola. The third one, graph a parabola in a rectangular coordinate system. Parabola has two kinds of orientation and equation. I will explain more of that later. But before that, let's discuss about the parts of a parabola. First is the vertex. Vertex is located at the midpoint between focus and directrix. Second one is the directrix. It is a line. It is a fixed line in a parabola. And next is the focus. It is a fixed point in a parabola. And then the last one is the axis of symmetry. It is a line which cuts through in the middle of a parabola to create a mirror. To better understand those parts, let's see those parts in a condition. A parabola is defined in terms of a fixed point, the focus, and a fixed line called the directrix. A parabola is the set of all points in the plane whose distance to the focus is equal its distance to the directrix. Let's talk about orientation of parabolas. This time we will going to discuss about horizontal directrix and vertical directrix. In horizontal directrix, the orientation of our parabola is either is either opening upward or opening downward. And the standard equation of a parabola opening upward or downward and its vertex is at the origin is x squared is equals to 4by. And the example of the parabola opening upward is this one. But how will we know if a parabola is opening upward or downward? So this one, if p is greater than 0, it means p is positive, the value of p here is positive, it opens upward. And if p is less than 0, it means the value of p here is negative, it opens downward. But what is p here? What is the value of p here? So p here is the distance between the vertex and the focus, or the distance between the vertex and the line of directrix. So from this graph, we're going to locate our focus. The location of our focus here is 0, p. Remember, if the parabola opens upward, the location of our focus is 0, p. But if our parabola opens downward, instead of positive p, it becomes negative p. Because if the parabola opens upward, the location of our focus is located above the vertex. But if the parabola opens downward, the location of our focus is below the vertex. So if the parabola opens downward, the focus is located at 0, negative p. Now let's talk about directrix. From this graph, the line of directrix is y is equals negative p. The line of directrix is horizontal. If it's horizontal directrix, the equation of the directrix is always y is equals to a number, or y is equals to negative p. It opens upward. But remember, if the parabola opens downward, the line of our directrix becomes y is equals to positive p. Y is equals to p. Why? Because When the parabola opens upward, it is negative because the line of our directrix is located below the origin. So it means it is negative. But if it opens downward, the line of our directrix is located above the vertex or above the origin. So it becomes positive. Last, the axis of symmetry, horizontal directrix is y-axis, the y-axis. Because the axis of symmetry is always perpendicular to the line of the directrix. Remember, if we have a parabola that its vertex is at the origin and it opens upward or downward, the axis of symmetry is always the y-axis. Remember that. So let's talk about vertical directrix. In vertical directrix, the orientation of our parabola is either opening to the right or opening to the left. And the standard equation of a parabola with its vertex at the origin is y squared is equal to 4px. So remember, in horizontal directrix, the standard equation of a parabola is x squared is equals to 4py. But in vertical directrix, the standard equation of a parabola becomes y squared instead of x squared and 4px instead of 4py. So remember, in vertical directrix, y squared is equal to 4px. An example of that is this graph. This parabola opens to the right. Again, the question is, how can we know the parabola is open to the right or open to the left? So again, the key here is the value of p. If p is greater than 0, it means it is positive. The value of p is positive. It opens to the right. And if p is less than 0, it means p is negative. It opens to the left. So again, the value of p here is the distance of the focus and the vertex, or the distance of the line of the directrix and the vertex. So from this graph, the graph is open to the right and the value of p here is positive. If the value of p here from the focus is positive, it opens to the right. But if our parabola opens to the left, our focus here is located, instead of p, 0, it is located at p, negative p, 0. But this graph, our focus is p, 0. So remember, if our parabola is opening to the left, the location of our focus, instead of positive p, becomes negative p, 0. So let's talk about the line of the directrix. Here in this graph, the line of the directrix is x is equals to negative p. Why negative p? Because as you can see, in the line of the x-axis, from the vertex, the line of the directrix is located to the left of the vertex or up to the left of the origin. And it means it is going to the left. It means it's decreasing. So from origin 0, 0, decrease, it means it becomes negative. So the value or the line of our directrix here is x is equals to negative p. But if our parabola opens to the left, the line of our directrix is located to the right of the vertex or to the right of the origin. So it becomes x is equals to p instead of negative p. Remember that if it is opens to the left, the directrix is x is equals to p. And for the last, axis of symmetry. In vertical directrix, the axis of symmetry is always the x-axis. Remember that. If the vertex is at the origin, that's the condition. So let's go to the example. We have example number 1. Graph x equals to 1/4 multiplied by y squared. we need to label the vertex, focus, and directrix. So we see here y squared. So we know that this is a vertical directrix. And the equation, the standard equation we need to use is y squared is equals to 4px. So let's see the graph. First, identify the p. To identify the p, we need to change this equation to standard equation of the parabola. So from this equation, it will become like this. So as you see, 4p, and this is 4 multiplied by 1. So p is 1. P is equals to 1. So we will indicate or label the vertex, focus, and the directrix. Since p is greater than 0 or positive, which is 1, the parabola opens to the right. So we know the vertex is at the origin, and to the right of the vertex, we will find the focus, which is 1 unit away from the vertex and located at 1, 0. And the directrix is located to the left of the vertex, and the line of the directrix is x is equals to -1 or negative p. What is our p? 1. So it becomes -1. So next is to graph the parabola. We need to graph this equation, this parabola, and to graph that, we need to set table of values. So use a table to sketch a graph. So we need to set the table values for y and substitute to this equation to find the values of x and then plot the points. If y is equals to 0, x equals 0, that's the origin. If y is equals to 2, x equals to 1, and 2, 1 is the first point. And if y is 4, and x is 4, and the second point is 4, 4. And if y is equals to -2, x is 1. The third point is 1, -2. The last, we have if y is -4, x is 4. We have 4, -4. And we will draw the parabola opening the right. That's the parabola. So let's move on to our second example. So we need to determine the focus and the directrix of the parabola with a given equation. So our equation here is x squared is equals to y. So we have x squared. So we all know that it is horizontal directrix. It has horizontal directrix. Also, we need to sketch the graph and indicate the focus, directrix, vertex, and axis of symmetry. So first, we need to have the position plane and plot the vertex at the origin. And we all know that the vertex has a coordinates of 0, 0. And the standard equation that we will go to use is for the horizontal directrix. We have x squared is equals to 4py. To be able to find the focus and the directrix, we need to find the value of our p. So from the given equation, we have x squared is equals to 12y. Notice that in the standard equation, we have 4. In our given equation, we have 12. Notice the value of 12. It's positive. So it means our parabola opens upward. So we have a parabola opening upward. Then, what is the value of our p? So to find the value of p, we need to equate 4p is equals to rho. And dividing both sides of this equation by 4, we will get the value of our p is equals to 3. It means the value of our p is positive, opens upward. And this value of P here indicates the distance of the vertex and the focus, and also the distance of the vertex into the line of directrix. So to find the focus, the location of the focus, so from the vertex, we're going to move upward because it's opening upward, 3 units upward. So here, that is our focus, and we need to locate this one. So the location of our focus is 0, 3. And next, we're going to find the line of directrix. So from the vertex, we're going below. We will go down. How many units? 3 units, because that's the value for P. So we go down 3 units. And that is the line of our directrix. And directrix is equals to y is equals to -3. Y -3. So if the parabola opens upward, the directrix is located below the origin or below the vertex. So the equation of that is y is equals to -p, and p is 3, so it is -3. And for the last one, we need to find the axis of symmetry. Since we have this standard equation, x squared is equal to 4p1, we have resultant directrix, and the rotation of our parabola is opening upward. So the axis of symmetry is always the y-axis. So then, and we're done. We will now find the focus, directrix, axis of symmetry, and we graph the parabola.